All right, this is it. This is the final lesson of geometry for this quarter. You won't have a mastery check on this lesson. It will be on the assessment. So please work through this carefully so that you are ready for the test. Now, we're talking about geometric probability. So how can we model probability with geometric models? Or how can we model probability problems with geometric models? Here's an example. Say you have a line segment and you're like, hey, what's the chance that if I put a dot randomly on this line, what's the chance that it will land between B and C? And as long as it's equally probable that the dot falls anywhere, let's try this. Let's put some random dots on that line. So I'm just going to randomly put a dot there. Not on BC. There. Oh, that wasn't quite a dot. Let's try again. It was like right there. That is on BC, right? So there's a chance that it falls on there. There's a chance that it doesn't. What is that chance? Well, that chance is just directly related to the length of those lines, as you see right here. The chance that it falls on there is just the length of BC divided by the length of the whole thing, AD. Let's do an example. That's my cat. Hi. Okay, so in this situation, we are using segments to find probability. Point K is on ST. Chosen at random. So we don't see it there yet because it hasn't been chosen yet, but it's going to fall in some random spot. What is the probability that K lies between or on segment QR, so between Q and R? They've given us some numbers here to work with. We're trying to figure out the probability that it lands here. So that probability is going to be the length of that segment divided by the length of the entire segment. So the length of QR, so our probability, oops, that's not what I want to write with. Our probability is the probability of K on QR is equal to the length of QR divided by the length of the whole thing, which would be segment from S to T, ST. And the length of QR is 3. The length of ST is, well, here, let me do I'm skipping some steps. The length of QR is the position of R, the difference between R and Q. So it's 8 minus 5. And the length of ST is the position of T minus the position of Q, the difference between those two. And so that is 8 minus 5 is 3, and 14 minus 2 is 12. So it is 3/12. Those are both divisible by 3, so that is also 1/4. So what is the probability? Probability QR is 1/4. Okay. Try a couple of those, and then we'll look at problem 2.